Welcome to Engage Math, Lesson 29, Problem 3, where we are using our knowledge of quadratics that we've done in this lesson to solve something called the Pythagorean theorem. Now, you may or may not have learned the Pythagorean theorem in the past. It's really not part of our Algebra 1 curriculum. However, it is a really kind of interesting theorem that you may have learned before, and you will certainly learn as you move on in math if you haven't yet. But the idea is that if you have a right triangle, always, based on the work of a great mathematician, Pythagoras, there is a theorem that says a squared plus b squared equals c squared, whereas a and b are the legs of the right triangle and c is the side opposite the right angle, which is called the hypotenuse. So if you look at the inside back cover of your workbook, you will see that the Pythagorean theorem is in there written just the way this one is. So we're going to use it twice to be able to find the distance from this upper right corner in the back to this lower left corner in the front. So that diagonal goes all the way through the box. So we're going to use the Pythagorean theorem actually twice. So the first time, I'm going to color code a triangle here, a right triangle. So, and we know that this is a rectangular box, so we can assume, or we know that we have right angles. So I'm going to start by trying to find that dotted red line. So notice that I have this triangle. Here's the 4, here's the 3, and then I'm looking for this dotted line that goes right across the base of that rectangular prism or the rectangular box. So this is the right angle. So according to the Pythagorean theorem, we can take the one leg of the triangle and square it. So I'm going to say 3 squared plus 4 squared equals, and I'm going to call this x, equals x squared. Okay, 9 plus 16 equals x squared. 25 equals x squared. And based on what we know about solving equations where we can take the square root of both sides, x is equal to 5. Now you might be thinking, wait a second, you were just told that when you take the square root of both sides and there is a variable x, that the side opposite the x, you're going to say plus or minus 5. The reason I'm ignoring the negative 5 this time is the 5 represents a side length, and a length can't be negative. So this little piece right here is 5. All right, now I'm going to change up our colors a little bit, and I'm going to find another triangle. This time, I'm going to use this triangle, which is also a right triangle. So I'm using the green line right over that dotted line that we know is 5. And this time, we're going to try and find the entire diagonal across the box, which is the hypotenuse of this green triangle. Notice, this is the right angle now. Now, the triangle, if you can picture it, this side is the 5, this is the 12. Do you see that green triangle? This becomes one of the legs, which is this side right here, and then the 12 is right here. So now we're going to say 5 squared plus 12 squared equals x squared, and once again, we're going to use our quadratic solving skills. So we're going to get 25 plus 144 is equal to x squared, and 169 is equal to x squared. So we are going to get that x is equal to 13. Okay, that is what we were looking for. That is the answer to our question. The only other thing we need is 13 centimeters. Now, there is a shorter way of doing this problem, but for right now, I like you solving those equations and looking for the Pythagorean theorem twice in this problem. But just so you know, I'm going to give you a formula here too that is not in your book. It's just a little shortcut. But the diagonal, or the D, the diagonal going across a rectangular solid, is always going to be equal to the square root of the length squared, which I'm going to kind of make a kind of a scripted L. So it's the length squared plus the width squared plus the height squared. Length, width, and height. And if you look at that, we would have the 4 squared plus the 3 squared plus the 12 squared would also give us the 169, and the square root of that is again 13. So either way, we're going to get an answer of 13 centimeters. Thanks for joining us at Engage Math.